Okay, so in this lesson, we're going to be learning another way of solving a quadratic equation. We're going to be using the quadratic formula. So the quadratic formula may be used to solve any quadratic equation. So it's the only one that we can solve any, okay? The blank states that the quadratic formula the quadratic equation ax squared plus bx plus c equals 0 has solutions at this. So you find a, b, and c after you've set it equal to 0, and then you're plugging into this formula, okay? Once you've plugged into the formula, then you're simplifying your solutions. So first step is to set it equal to 0. So that's what we're going to do first. So it doesn't matter which side you move to, but again, I like to always keep my x squared positive since that's what we have to do when we're factoring. Okay, so I'm going to find a, b, and c. So a is the coefficient. Here's your standard form. So a is 8, b is -6, and c is -5. Okay, so I'm going to plug in. So x equals, here's your formula up at the top. Negative b is on the formula. B is already -6, so it makes it +6. Plus or minus the square root of b squared, so -6 squared, minus 4 times a, which is 8, times c, which is -5. Divided by 2 times a, so 2 times 8. Okay, so after you have plugged into your formula, you need to find this piece that's under the square root. Do not type in the square root. You type in everything that I circled in blue. Make sure that you're putting parentheses around -6 before you square it on the calculator. So you're typing that into the calculator if needed. So when you do that, you should get 196 underneath the square root over 16 there. So then you're simplifying the radical if possible. The square root of 196, it is a perfect square. It equals 14. So you actually have to work it out. Notice that we don't have a radical anymore because the square root of 196 was a perfect square. So we need to work it out. So I'm going to have two different answers, 6 plus 14 over 16 and 6 minus 14 over 16. So you should get 5/4 and -1/2 for your two solutions. So make sure if you do not have a radical in your answer because it was perfect, make sure you work it out and find those two answers. Sometimes you can leave it like that. That's if you have a radical. Okay, let's try another one. First thing is to set it equal to 0. Notice this one's already set equal to 0, so I need to find a, b, and c. So a is 3, b is -30, and c is 85. So I'm plugging into the formula. It's -b, b is -30, so it makes it +30. B squared, so -30 in parentheses before you square it, minus 4 times a times c. Make sure you look at the formula carefully when you plug in, over 2 times a. So again, after you've plugged it into the formula, this piece you are plugging into the calculator to find what it equals. You do not plug in the square root. You only plug in this piece, and make sure you put parentheses around the -30 before you square it. So you need to type it all in. You should get -120. Okay, so after I've done that, I need to simplify it. The last one was a perfect square on the square root part. Notice this one has a negative under the square root, which means I should have an imaginary solution. So I'm going to go ahead and make it an I and then take the square root of 120. All right, so 120 is not a perfect square, so I need to use factor tree to simplify it. So I have a pair there. So whatever you have a pair of, remember, comes on the outside. So I'm bringing a 2 on the outside. Don't forget your I. And then I need to multiply everything that didn't have a pair. 2 times 3 is 6, times 5 is 30. Okay, so on this part, make sure you're looking at all of the outside numbers. The only way you can reduce all 3 of them is if all 3 of them have something in common. Notice all of them are divisible by 2. So I can reduce all of them by 2. That would be 15 plus or minus just a 1i. Never touch the 30 under the square root, and then that's over 3. So I divided this, this, and this. So you have to check all 3 of those numbers. If they're all divisible by the same, you can reduce it. You could also, if you wanted, split it up into two different pieces. That could be a 5. So I'll accept either answer there. Or you can just write it like that. So this is the quadratic formula. It works for real solutions and imaginary solutions. All right, let's take a look at this word problem. So we're given the function h of t equals negative 0.8t squared plus 2t plus 1. It represents the height in meters of a ball thrown upward in an initial velocity of 2 meters per second from 1 meter above the surface of the Earth's moon. T is going to represent the time in seconds. Use the quadratic formula to determine when the ball will reach the ground, which means y equals 0. That's your y. Determine the domain of the situation and justify your response. So, I know I want y to be 0. So if I replace my function or my y with 0, this is what it looks like. Now I can find my a, b, and c. So a is always the number in front of x squared. In this case, it's a t, so that's negative 0.8. b is 2, and c is 1. So we are solving for t here. So the formula is negative b. b is 2, so it makes it negative 2, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So make sure you know the formula. Write it down every time if you need to. So remember, once we have plugged it in, we're going to need to find this number under the square root. So type that into the calculator. You should get, without the square root, you should get 7.2. I'll round it. And then 2 times negative 0.8 would be negative 1.6. Okay, so let's think about this situation. We're wanting to know when will it reach the ground. So we know that we should not get a negative answer. So you're on the real world situations, you're welcome to type this into the calculator. I would recommend typing in the numerator first, press enter, and then divide it by your denominator. So your two answers, you should get negative 0.04271, and then the other one would be 2.9271. So again, we're trying to find when will the ball reach the ground. We're not dealing with negative seconds, so it would be 2.9271 seconds. Your domain of the situation, domain is your x, which in this case was t, so seconds, time in seconds. It started at 0 and it went to 2.9271. You can use interval notation. So that would be your domain of this scenario. Okay, let's flip it over. The back, we're going to be looking at just the discriminant. So sometimes you just need to know, would this be imaginary solutions, real solutions, how many? So there's a way to do that. The discriminant is just the piece that's under the square root, the b squared minus 4 times a times c. That's the piece that we've been looking at once we've plugged it into the formula. So the discriminant can help you determine the number of solutions and whether the solutions are real or imaginary. So if your discriminant, when you work it out, just the b squared minus 4ac, if it's greater than 0, which means positive, that means you have two real solutions. This is what it looks like on a graph. Crosses at two different places on the x-intercept or x-axis. If it's equal to 0, that means you only have one real solution, which we looked at when we were graphing. That meant the vertex was also the x-intercept. The reason there would only be one is because if you add or subtract 0 from a number, you get the same exact thing. That's why there's only one real solution there. The third one, if your discriminant is less than 0, which means negative, that means you're going to have two imaginary because you would have a negative under the square root. Graphically, it doesn't cross the x-axis, so there's no x-intercepts. So part 3, we're going to determine the number and type of solution to the quadratic equation. Justify your answer. First thing I have to do is set it equal to 0 and put it in standard form. Find A, B, and C. A is 2, B is 6, C is 7. To find the discriminant, it's b squared minus 4ac. So that would be 6 squared minus 4 times 2 times 7. Okay, so you should get, when you work that out, negative 20. Since I got a negative, that means I would have two imaginary, because there would end up being a negative under the square root. Okay, let's try another one. So it's already set equal to 0. A is 25, B is negative 80, and C is 64. So that would be negative 80. Make sure you put it in parentheses, squared. Minus 4, A is 25, C is 64. So you're working that out. You should get 0 when you work it out. So if it's 0, that means you only have one real solution. Because if you add 0, subtract 0 on your formula, when you're solving, you get the same number. So that's why there's not two. All right, last piece. We have another word problem. The function y equals negative 2/3 x squared plus 2x represents the vertical distance, y, in feet traveled by a grasshopper, and x represents the horizontal distance. Use the discriminant to determine if the grasshopper will reach a height of 3 feet above the ground. So that's the vertical, which would be y. So when I plug into my formula, I know where y is. I'm going to put a 3 in place of it. So what I'm going to do is plug in for y, and then I'm going to set it equal to 0. So I'm going to subtract 3. So now I'm going to use the discriminant. So A is negative 2/3, B is 2, C is negative 3. So we're using the discriminant formula, just the piece that's under the square root, to see if this would even be possible. So 2 squared minus 4 times negative 2/3 times negative 3. Okay, so if you can plug all that into the calculator, just use parentheses where I have parentheses. When you plug it in, you should get a -4. If you get a negative, that means that would be imaginary because it would be negative under the square root. That's not possible in a real world situation. So the grasshopper will not reach a height of 3 feet above the ground. Okay, next piece. Use the discriminant to determine if the grasshopper will reach a height of 1 foot above the ground. Above the ground is vertical again, so that's still talking about y. So this time y equals 1. So just plug that in place of your y on your equation up at the top, or function. So set it equal to 0. So subtract 1. So A is -2/3, B is 2, C is -1. So plugging into your discriminant formula, you have 2 squared minus 4, A is a -2/3, C is a -1. So again, work that out in the calculator, plug it in. You end up getting 4/3 or 1.333 repeating. So since you end up getting a positive, this is possible. You're going to get 2 different solutions here. So since it's positive, yes, 2 real solutions. So it does reach 1 foot above the ground. Okay, this is using the quadratic formula, and then on the back we were just looking at the discriminant piece, which is just the piece under the radical to determine what type of solution we would have. If you have any questions, let me know.